Hey everybody, Trey here. Welcome back to another video. Out here on the road near the Wichita, Kansas area for today's chase, but wanted to give you a forecast discussion on a potentially potent severe weather setup for today across the central and into the southern plains. We've got a moderate risk out for parts of southern and southeast Nebraska up into northern and northeast Kansas, surrounded by a pretty broad enhanced risk here that extends all the way down almost to the Oklahoma City metro area, including parts of pretty much the eastern half of Kansas up into surrounding areas of Nebraska. So, definitely a potent severe weather risk in the eyes of the SPC today. We'll have, number one, a significant tornado threat today. And the threat is going to be kind of multi-mode, and we'll give you the details on both and kind of the pros and cons of both as far as tornado potential goes. But the SPC has highlighted a 10% hatched area for tornadoes. Some could be strong to significant here in this 10% hatched area from southeast Nebraska, including Lincoln, down toward Wichita, and even toward closer to the Tulsa, Oklahoma area along that I-35 corridor into northern Oklahoma. Damaging winds also going to be a significant threat, perhaps significant damaging winds, especially up there in that moderate risk area. And that's the reason for the moderate risk is this significant damaging wind threat up there, surrounded by a 30% hatched area for damaging winds as well. And large hail is going to be a threat with storms, especially in the initial phase of thunderstorm development today. So all hazards are on the table today, perhaps some significant hazards. And so we're going to get you started here and talk about kind of both of these areas. The first area is going to be in this kind of moderate risk area up here in southern Nebraska, northern Kansas. And then the second target is going to be down here along the dry line from central Kansas down into potentially as far south as the Red River. So we'll go into both targets, get you acquainted with kind of the pros and cons as far as at least from a chasing perspective for severe weather in both of these target areas, and then we'll kind of give you an overall kind of progression of the event as well. So we'll start out looking, as we always do, with the satellite image. This is the upper level water vapor imagery, and you can see it's not really this high amplitude feature that we're talking about today. You can see definitely this kind of troughiness here, but it's not this real deep digging trough that we've seen pretty often this season. It's going to be a nice lower amplitude feature, and that tends to be more favorable for supercells, especially along the dry line here, and that's going to be the case today because your forcing just isn't quite as strong. Your winds aloft are more out of the west or kind of west-southwest. So oftentimes your shear vectors are going to be almost perpendicular to the initiating boundary here. That's going to be the case along the dry line today. We'll take a look at that shortly here. Up on the to the north of the surface low, we'll take a look at the surface map here in a second. We've got a surface low out here in western Kansas. We've got storms ongoing here across a broad swath from central Nebraska down through eastern Nebraska, eastern Kansas, into western Missouri. And if we take a look first here at the visible satellite imagery, you can see those kind of colder cloud tops there, those overshooting tops here within these kind of masses of thunderstorms. A couple of things to note on this visible satellite image right here. So number one is going to be this boundary that is sagging southward a bit across central Kansas. This is going to be pretty critical today. This appears to be an outflow boundary from these overnight complexes here. And so wherever this sets up could be a focus for intense severe thunderstorm development this afternoon, particularly where it intersects with the dry line. So the dry line is going to set up somewhere here across central Kansas, and wherever this outflow boundary intersects with that dry line is going to provide a little bit extra lift, a little bit extra convergence there at the surface to allow storms to fire in a potentially otherwise conditional setup. And we'll talk about the conditionality of the setup here in a second. But that may be a focus for severe storms, and of course along this outflow boundary, we're going to have a pretty decent area of enhanced wind shear, especially low-level wind shear along this boundary. So I'm going to have to monitor this very, very closely, as this could provide just enough lift to get a storm or two to go. And if it rides this boundary, could be some significant severe weather associated with that storm. So it looks like there may be another boundary emanating from this complex up here in Nebraska. You can kind of see this fine line there within that kind of massive cloud sagging toward the southeast a little bit. That may be another boundary as well we'll have to watch as we go throughout the morning and early afternoon hours. But definitely some interesting features here on the visible satellite image at this point that could be critical for the severe threat this afternoon. So this is the current radar here. So we've got few different complexes of storms here. This first one across central Nebraska. And would expect these storms to weaken as we go throughout the morning, as we're kind of dealing with a stable low-level atmosphere at this point The forcing not quite here yet. So I would expect these storms, as they move away off to the east, that they will weaken a little bit as we go through the day today. Same thing here across northeast Kansas, far northwest Missouri into southern Iowa. We've got these kind of two areas of convection here, moving out of Kansas into Missouri, into Iowa this morning. And again, these should weaken as we go on through the day. They don't really have any support to keep them going this morning. So that is going to be something to watch as well. As if these storms continue to weaken throughout the morning, this boundary, and you can see this kind of outflow boundary here, kind of see that fine line there in the radar reflectivity. I'll try to pause it right here for you so you can see where this fine line is. You can see where it extends. It's kind of area of slightly higher return there. That's going to be our outflow boundary, and again, it's sagging a little bit south. And if these storms continue to weaken, and again, this part of the outflow boundary is moving, the storms are moving away from it. So we're not really having support for this outflow boundary to continue to surge south. If we were dealing with a situation where we had a large complex of storms just to the north of it, continue to stay strong throughout the morning, this would just continue to surge south well into Oklahoma likely. But that's not going to be the case today. We don't have a lot of support for that to continue to surge south as we go through the day today. As these storms weaken and move off to the east, this should stall out, I would think, somewhere across southern Kansas, southeast Kansas, maybe as far as the Kansas-Oklahoma border. It may actually retreat a little bit to the north as well. If we look at our surface map here, right now, let me refresh this just so we have the most up-to-date data here. So you can see exactly where that wind shift is across central Kansas right now. You can see these south-southeasterly winds to the south of it, easterly winds to the north of the boundary. So clearly an outflow boundary in here. And again, once we have these storms kind of decay fully, this boundary should stall out and maybe even retreat a little bit northward. As if you look at the orientation of the winds here, you can see easterly winds to the north and at about 5 to 10 knots or so. And you can see to the south, we've got about 20-25 knots of south-southeasterly flow. Well, if we've got stronger flow going this way than we do to the north of the boundary, this boundary may start to retreat northward a little bit throughout the day. So the position of this outflow boundary is going to be key as far as the dryline severe weather threat goes. Wherever that sets up is going to be where you'd want to be for intense thunderstorm development this afternoon. So something for sure to watch for this southern portion of the target area. At this point, you can see we have that surface low out here across eastern Kansas. You can see that cyclonic circulation there, low centered somewhere over there. And we've got it's kind of hard to tell. The warm front looks to be somewhere up in here at this point. You can see kind of the temperature gradient there. A little bit of a wind shift, easterly winds to the north, to the south of the boundary, northeasterly winds to the north of that boundary, or almost due easterly winds here. So somewhat of a wind shift here. So that's probably where the warm front's located at this point. And again, down here is going to be your outflow boundary. I'll do that in blue as well. And then our dry line is going to set up somewhere across central Kansas, western Oklahoma, to central Oklahoma today. Right now, you can see at Amarillo, 69 over 14 degree dew point there at Amarillo. So very, very dry air to the west of this dry line, which at this point looks to be somewhere in here. Might be a little bit wavy there. But it's definitely going to strengthen as we get this surface low to move off to the east throughout the day and strengthen and deepen. We should get these winds to continue to pump this moisture northward to the east of the dry line, and that dry line will really start to set up somewhere in central Kansas into western Oklahoma, feeding up into that surface low as it moves off to the east today. Surface moisture looking pretty good. We have low to mid 60s here, especially with southern extent across Oklahoma. You can see we've got about mid 60s dew points down here toward the Red River, decreasing a little bit with northern extent. But given the strength of this low, I expect these decent surface dew points will stream northward pretty quickly as we go throughout the day today. Now, where's our reservoir of higher dew points? That's all the way down here into Texas. You can see these 66 dew points down here into south central Texas. Not quite sure if we're going to get those all the way up to central Kansas by this afternoon, by initiation time here. So we may be a little bit lacking on the moisture side of things, but definitely more than adequate for supercell development later on, these kind of low to mid 60s dew points. I feel like we should get at least 64, 65 dew points up here into central Kansas. With northward extent, it's a little bit more questionable. So we have kind of 50s dew points up there right now along that warm frontal zone. So something to watch for sure as we go on throughout the morning, and so a little bit of a closer look here at the surface map across Kansas. This is the Kansas mesonet, so it gives us a little bit more of a fine scale look at things here, and you can see exactly where that outflow boundary is. It's going to be somewhere along here, this corridor here. You can see we have clearly south-southeasterly winds, 15 to 20 knots here to the southeast, almost due easterly winds to the north of that boundary. So clearly an outflow boundary here that again is sagging slightly south throughout the morning hours today. So let's look at our broad scale picture here. So this is going to be our trough, beautiful negatively tilted trough here at 500 millibars, 18,000 feet or so. So this is a very nice negatively tilted trough that's going to eject into the plains this afternoon, and this is going to be timed pretty well with peak heating. You can see it's right here. It's probably going to end up, the axis is going to end up somewhere off to the east a little bit there. So we have our exit region of the trough nicely across central Kansas into southern Kansas here this afternoon. You can see the flow is not overly strong with this trough. We're still kind of seeing a maturing trough. Most of the flow is relegated to the backside of this trough. Throughout the day, though, that should kind of rotate around the base of that trough, and we should get a pretty beautiful exit region to develop across central to southern Kansas here as we go through the day. You can see nice defluence aloft. Again, that's the spreading apart of the wind vectors with height. You can see how nicely they spread out here. So very nice defluence here across the central plains for today here with this 500 millibar trough. Let's go down to 700 millibars, identify some short waves here. So you can see where that kind of circulation is centered across kind of northern Wyoming, southern Montana there at 700 millibars. Pretty well-defined shortwave there that's helping these storms ongoing right now to continue throughout the morning. Perhaps another little shortwave in here, maybe one back in here that may be a player for today's severe weather threat as it moves off to the east. Very subtle, though, rounding the base of this kind of broader, kind of long wave trough here at 700 millibars. Let's go down to 850 millibars, take a look at our low-level jet. And something's kind of up here with the SPC site, but the shading here is the winds, the magnitude of the wind here. So very strong low-level jet across the southern and central plains at this point, across eastern Kansas, kind of centered, maximized across western Oklahoma there, 40, 50 knots there of flow. Now, one thing you'll notice here, these wind barbs are coming out of the southwest, and that's going to be interesting, something interesting to watch today as well. If we take a look at some soundings, so let's start with the Norman sounding. This is the 12Z, 7 a.m. sounding from Norman, Oklahoma. And you can see we have a decently deep moist layer, but one thing you'll note is that how the moist layer has kind of shrunk a little bit from last night. If we go to 0Z last night, so 7 p.m. yesterday evening, you can see how deep the moisture is. It goes up almost to 700 millibars, about 750 millibars or so. Now, if we go back to our 12Z sounding here at Norman, you can see it's decreased in height a little bit. Well, that's because these 850 millibar winds are coming out of the southwest. And what resides here to the southwest of the central and southern plains? Well, it's this dry, warm air here across northwest Mexico into the desert southwest that's being pulled in by this southwesterly low-level jet. So we may be dealing with some dry air aloft here. You can see the elevated mix layer is very, very stout here across the central and southern plains today, at least at this point. You can see large instability has already begun to build here, but this cap is going to remain in place throughout much of the day. You can see the maximum 2 to 6 kilometer lapse right here, 9.4 degrees Celsius per kilometer, so extremely steep lapse rates aloft here in this regime. So very large hail. I never want to use the word gorilla hail, but the hail could be extremely large today, 3 to 4 inches perhaps, given the very, very steep lapse rates aloft. Now, the low-level shear will be strong, and that tends to be kind of a negative correlation with the hail size and hail production within these storms. But nonetheless, we have very, very, very steep lapse rates aloft, given this elevated mix layer here. So very large hail is going to be certainly a threat with any storm that does fire today. But the question here is, are we going to get storms to fire across this southern portion of the target area? This cap is pretty stout. If we look at our convective temperature, 94 degrees here at Norman. So we're going to have to heat up quite a bit to get storms to go. But the good news today, whereas we've had some of these previous events here over the past couple weeks where we don't have strong forcing to help lift and cool this capping inversion, we are going to have strong forcing today. This 500 millibar trough, very, very strong, and will definitely help lift and cool this capping inversion. With southern extent, though, will it be enough? If we look at our Topeka sounding, we have to take this with a grain of salt. This is likely convectively contaminated here, as there were, as you saw on the radar, plentiful storms out in this area this morning. So this is likely convectively contaminated. But if we consider that we have this kind of cap here on the atmosphere, these storms ongoing are pretty elevated at this point. We say this is a decent representation of the cap here. Our convective temperature is 85 degrees. So we're sitting at 61 here at 7 a.m. in Topeka. Our surface temperatures here still in the low 60s up there into northeast Kansas. Definitely greater with southern extent here across central Kansas, up into the mid to upper 60s at this point across central Kansas. So if we can get into the low to mid 80s and get close to that convective temperature, plus we have the forcing, the pretty significant forcing from this negatively tilted trough moving in that will help lift and cool that cap, I have a decent suspicion that we will get convective initiation along the dry line, at least in central and perhaps southern Kansas throughout the day today. I do think this cap will be breakable with northern extent, and it's a little bit of a shame that we don't have a sounding out here kind of at Wichita. Now this is at Dodge City. This is to the east of the dry line at this point, but this is extremely, extremely dry air here, very much closer to that dry air source here in Dodge City than we are at Wichita. So if this were the case across to the east of the dry line, we would definitely not be getting storms today. This is a very, very stout cap, very strong elevated mix layer here. But we do have a strong trough in place, so if this is the case to the east, kind of taking kind of an average between the Dodge City and Topeka soundings here for that kind of pre-dry line area this afternoon, I do think the cap is going to be breakable today, given the strength of the forcing aloft, given that we should have surface heating today. If we look at the satellite map, we are pretty clear across central Kansas at this point. This cluster of storms, these anvils are moving off to the east. We do have this kind of boundary here that's sagging to the south and these kind of stable low-level clouds here, but would expect those to burn off as we go throughout the day and get pretty decent surface heating. I would expect that the cap is going to be breakable across the central and southern Kansas region today, particularly as that's going to be where that main forcing is going to set up. That left exit region of the trough is going to be right over central Kansas. You can see where that exit region is. So if we consider that the trough is going to be somewhere in here, we'll have our exit region right over central Kansas. So right at the bullseye there, central to southern Kansas, I think it's very, very plausible that we will get convective initiation there this afternoon. Especially given the strength, the intensity, and kind of tightness of the dry line as well, which we'll take a look at here in a second. Okay, so let's look at some model data here. This is the 12Z NAM coming in as we speak. So you can see that negatively tilted trough coming in, ready to eject into the plains as we go through the day today. So this is at 21Z. This is at 4 p.m. Central Daylight Time, and you can see exactly what we're talking about here. Beautiful defluence aloft, kind of an area of enhanced sort of winds here, rounding the base of that trough. So your main winds, kind of stronger belt of flow is to the backside of that trough. But you can see that exit region is right here over central Kansas, this left exit region, which is typically most favorable for severe weather. And we're not going to get into why that is at this point. That's involves some pretty decent look at the primitive equations of meteorology here. But the left exit region is often the most favored region for severe weather. And that's going to be right here over southern Nebraska and central to southern Kansas. Down here into Oklahoma, we're a little bit closer toward that base of the trough, a little bit less impact from that, or sort of the characteristics of that exit region down here to the south. So the threat down here is going to be a little bit more conditional across northern to central to southern Oklahoma there. So let's go ahead and go through a little bit more here. This is at 0Z. You can see that trough still kind of this low amplitude feature here. Not this extreme sort of deeply digging trough that's going to be, force an overforced mess here, instant squall line. Let's go down to 700 millibars, see where our short waves are going to be as we go throughout the day today. So again, this is at 4 p.m. So we have perhaps a short wave in here, maybe one actually kind of right in here. It's a little bit difficult to say, quite subtle here. We're looking for these little kinks in the flow within this kind of broader circulation here. So a couple of short waves, potentially very subtle short waves that may help things out a little bit, help initiation a little bit as we go through the afternoon hours. This is 850 millibars today, and that low-level jet is going to stay in place throughout the day. You can see it doesn't really go anywhere, given that kind of continued lead cyclogenesis to the east of the Rockies. Very strong low-level jet in place, going to expand across much of the region today. You can see 30, 40, 50 knots here, all the way up to Minnesota, down through eastern Nebraska, eastern Kansas, into much of Oklahoma there. So very strong low-level winds here. And they do eventually become more southerly here, so that may help a little bit. Perhaps at the last second, pump a little bit more of that moisture here, low-level moisture from the Gulf up to the north, instead of bringing that kind of drier air in from the southwest. As we have this morning, these winds are very much out of the southwest, almost west-southwest here across western Oklahoma. That may help bring some little bit more moist air as we go in through the afternoon hours, especially the late afternoon hours, but will it be enough? And will that dry air aloft be much of an issue? Again, the soundings here, we look pretty decent dry air aloft here. So is that going to be a huge issue? I'm not convinced it will be, maybe with southern extent here. Across Kansas, I think, given the degree of forcing, given the stoutness of the dry line here, which we'll take a look at right now, I think we will get convective initiation there in central and southern Kansas, or at least we stand a good chance to. Not certain for sure, but definitely is a possibility. Now, with this northern target, we're going to be kind of sitting here. This low, you can see where the surface low is, eastern Kansas, kind of Colorado border. It's going to deepen and move off kind of toward the east as we go throughout the day. So this is, again, at 4 p.m. Central Daylight Time. The low centered right in here across kind of west central Kansas. And you can see exactly where the dry line is, where these wind barbs are converging. You can see the winds out here west-southwesterly there to southerly there to the east of that dry line. Now, let's go ahead and zoom in here and take a look at our, let's go ahead and take a look at the floater sector here. So here's our surface low, 4 p.m. You can see exactly where the dry line is. Take a look at these surface temperatures, though. This is the NAM, of course, and we talk about this over and over again, how the NAM has a cool bias. It usually underdoes the surface temperatures pretty significantly, and I think today is no exception. At least right here along the dry line, it does get pretty warm, it looks like. But to the east of the dry line, this would suggest a very, very stable, very, very capped atmosphere, given upper 60s surface temperatures. Now, if we look at our Kansas mesonet here, we'll take this reading right in here, 67. It's already 67 degrees at that site, which is going to be basically McPherson. So the NAM is definitely underdoing surface temperatures here today. And if we were to take a sounding here, and we'll show you the dry line here. I'm going to zoom back out a little bit, kind of give you the whole southern central plains sector. So the dry line here, you can see very, very stout dry line here by 0Z. This is 7 p.m. Central Daylight Time tonight. Very stout dry line here, very tight dry line. You can see dew points in the 20s. Changing to mid-60s dew points here as you go across that dry line. So very, very stout dry line. Surface low somewhere in here, that moisture feeding up into the low, up here into northern Kansas, southern Nebraska. Again, that warm front kind of somewhere in there, I would assume, as it feeds into the low. But let's take a couple soundings here. You can see the NAM does have mid-60s dew points up into most of eastern Kansas today. And we're going to have to watch how fast that advection does happen as we go throughout the day today. And so let's compare here. This is the 12Z NAM moisture. We'll go to the current surface map. So we're seeing about 60-degree dew points or so up here into central Kansas, with kind of low to mid-60s here into Oklahoma. And that's a decent depiction here. Maybe a little bit more aggressive here on the NAM with moisture advection, but not too far off, it looks like. So actually a decent depiction. So the moisture may actually get here in time. These kind of mid to upper 60s dew points may make it in time here into the eastern Kansas portion of the target area, especially with southern extent. They pretty certainly will here into Oklahoma, but up into eastern Kansas and northeast Kansas particularly is still a question. But let's take some soundings here. We'll take one here kind of closer to the warm front, kind of on the triple point there. Again, that triple point is that kind of interface between the warm front and that kind of dry line / any cold front that will be in play today. Then we'll take one here across east central Kansas here, kind of north of Wichita there a little bit. Then we'll take one here down at Oklahoma City, farther south along the dry line. So this is going to be the northern target. You can see ample instability here, over 3,000 joules per kilogram of mixed layer CAPE here by 0Z, 7 p.m. Central Daylight Time. Does remain a little bit capped here on the NAM, but again, 68 degrees is the surface temperature here up in the northern portion of the target. Is that going to be the case? Not sure. The temperatures definitely are a little bit cooler now up there, but they're already into the low to mid 60s up here into southern Nebraska, so would expect that to be exceeded as well. Now the photographs here are a little bit more interesting. This is a little bit farther removed from the main forcing, from the main sort of belt of enhanced flow here rounding the base of this trough. So the photographs are not quite very long. And another thing here is we've got this little bit of a kink, a little bit of some backing in the mid-level winds. And usually that's not going to be too much of an issue here today, but notice that the storm motion is kind of going right into this sort of kink in the photograph. So this is the bunker's right storm motion, so we're assuming that supercells are going to occur, and the storm motion going right in here into the kink. And if we imagine supercells firing, they're going to follow the photograph. So the precipitation is going to be backed here. It's going to be vented right ahead of the mesocyclone, which would be in this portion of the supercell. So we may get a much more HP, high precipitation, much messier mode up here across that triple point. So that is going to be something to watch up there as well. Now farther south, this is going to be central Kansas, and we've got a little bit of a convective signal here at 0Z across central Kansas. But we do have pretty strong low-level curvature in the photographs. These photographs definitely are a little bit longer. And you can see that the storm motion is well away from the photograph. So if storms do fire down here into southern Kansas, they will be a little bit more of your classic supercell mode. Now the winds aloft are going to be a little bit weaker. So we may see a little bit more of an HP mode here. These kind of average wind here in this kind of in the mid levels here, probably about 40 knots, which is kind of right on the verge between HP, high precipitation, and classic supercells here. But the photograph does suggest that we may have a chance to see more of a classic mode, given that the storm motion is going to be well away, the precipitation going to be vented a little bit away from that storm motion. So the tornadoes may be a little bit more visible if the storms do fire. Now, that's the question. Will storms fire here along the dry line? NAM showing 73 degrees surface temperature here across east central Kansas. And again, we already have that. We're already 6 degrees away from that here across east central Kansas here. 67 here at McPherson, 65 at Elmdale here. So definitely we're going to breach that 73 degree temperature here on the NAM, given that we're almost already there and that we are pretty much seeing sunshine here across the area. Some low clouds do exist, but those again should burn off as we go through the day today. So I do have a suspicion that we will get convective initiation across central and southern Kansas, maybe east central Kansas, right along that dry line there. Given the strong convergence along the dry line, the kind of minimal cap that should be in place by this afternoon, and these warmer surface temperatures than what the NAM is showing here. But large looping photographs would definitely be would exhibit a tornado threat, perhaps a strong tornado threat, as well as large hail, given the very steep lapse rates aloft and damaging winds as well. Now this is farther south into Oklahoma, and this again is going to be the question. The NAM does have the temperatures going up into the upper 70s here, and if we go to our surface map, we already are seeing kind of about 70 degrees or so there across central Oklahoma. So will we exceed that 79? I think we may get into the 80s there as well. So that could be just enough to erode that cap. Again, Oklahoma going to be a little bit, just a tad removed from that exit region. So the forcing may not be as strong down here. But nonetheless, photographs are very, very favorable for supercells, perhaps tornadic supercells, lots of curvature in the low levels there. And decently long photographs as well, steep lapse rates aloft, so very large hail with any supercell that does fire. Again, with southern extent, a little bit more conditional there. But any storms that do fire will be isolated. We'll have a threat for all severe hazards. One more thing here, let's take a look at the shear vectors here and how they are related to the initiating boundary. So this is going to be at 21Z. So there's your dry line there. These vectors are basically the effective bulk shear. You can see down here along the dry line, they're almost purely perpendicular here, especially into central Kansas. So the discrete mode is going to be very, very likely with any storm that does fire here into central Kansas. Up here, the vectors are enough off of the warm front, but they do kind of follow that warm front up here. So we may get a little bit more of a messy mode up there as well, that's what we were kind of talking about there earlier, and you can kind of see now that cold front really starts to impinge on the warm sector there by just after dark there. So once the cold front takes over, we should get a linear mode at all locations within the target area. So definitely a multi-mode setup. We'll take a look at some cams here for you just to kind of give you a decent picture of what the radar might look like later on. So this is the 12Z HRRR run. So you can see it's got the storms out here into Nebraska as well as into eastern Kansas. Those move off. And we kind of get a very quick transition to a messy linear mode there, a clustered linear mode there across southern Nebraska, northern Kansas. And the HRRR keeps the dry line from convecting. So let's take a sounding here. And so, well, the HRRR is pretty close. It's uncapped here for the most part by 0Z, 7 p.m. Favorable photographs, but it does not convect anything here. Up along the surface low target, we've got a convective signal, very strong convective signal there, but large cape, large looping photographs there. So embedded tornadoes as well, but I think the mode is going to be pretty messy up there, up into southern Nebraska, northern Kansas. Not quite convinced that we're not going to see anything there in central Kansas. It does have the cold front firing as it impinges into eastern Kansas, even down into Oklahoma. It has quite a few storms firing in sort of a linear fashion along that cold front. Let's take a look at the WRF ARW here. So it does have the convection there, the morning convection. And the ARW, wow. So the ARW is very interesting here. Again, it fires more of a linear clustered mode up here earlier on, and that's another thing to note. Storms are going to fire up here in the moderate risk area, or close to the moderate risk area in the northern portion of the target first. We may see tornadic storms up there first before they congeal into a line, and the dry line is going to fire later if it does fire. And the ARW does have several supercells fire here along the dry line, one up here into northeast Oklahoma and one up here into kind of northeast Kansas. This one in northeast Kansas would definitely be the one to watch for a significant tornado threat as it goes on toward the Kansas City area eventually. But interestingly enough, the WRF ARW is firing supercells. Let's take a look at the NSSL WRF. It doesn't really have a great depiction of the current convection here ongoing this morning. But the NSSL WRF, wow, the NSSL WRF does fire some supercells out here. And it fires them all the way south here into central and southern Oklahoma. So the NSSL WRF has been pretty consistent with this supercell threat into central and southern Oklahoma with the last few runs. So that will be something to watch for sure. And then finally, we'll look at the FV3. Not a fan of the FV3 so much as it kind of overdoes convection, but has multiple supercells firing down here along the dry line from northern Kansas down into northern Oklahoma, more of a clustered mode up there in the northern target. So all in all, a potent severe weather threat on tap for today. Again, moderate risk up there for a small portion of southeast Nebraska, northeast Kansas, mostly for a significant damaging wind threat given the more linear mode up there, but strong tornadoes possible down there, up there, as well as down along the dry line with any storms that do form. Much more of a conditional threat down here along the dry line, but again, I think given that the forcing is kind of aimed right at east central Kansas there by this afternoon, the intensity of the dry line, and the fact that the models are definitely underdoing the surface temperatures, I do think it's very, very possible that we will get convective initiation down here into central and southern Kansas. Much more conditional with southern extent, a little bit stronger capping down here, a little bit slightly removed from the forcing down here into central Oklahoma, so much more questionable storm initiation down here into central Oklahoma. But will be something to watch for sure. We'll have a damaging wind threat and a very large hail threat as well, given the very steep lapse rates aloft. The northern mode, not expecting as much of a hail threat, particularly in the first couple hours of convective development when the storms are a little bit more semi-discrete. But down here along the dry line, if the storms do fire, they will pose a very large hail threat, perhaps larger than 3 inches or so. But we'll have to wait and see for that if storms actually do fire. So that's all I have for now. Thanks for watching, and we will see you in the next video.